All right. Good morning, everyone. Today we are going to talk about all the fun and excitement that comes with commercial lighting controls and how all of this is going to work, with energy and how we're designing things and how we're implementing things out in the field. So let's go ahead and get us started here. All right. So, my absolute favorite section of the code happens to be C103.2. And I appreciate C103.2 because it provides us with a list of items that need to be placed on the plan so that we're able to function and get things that we need to be able to determine that we're going to be able to get code compliance for our lighting controls. Now, the idea is there's an awful lot of things that the energy code does. And one thing that it's very, very good at is control, right? We have controls for mechanical, we have controls, that deal with, even with the thermal envelope, but more importantly, we have controls that hit upon when it comes to our lighting. Because way back when, our lighting used to be one of the components that a structure utilized the most energy for. Often people think about uh, space heating as being a huge piece of the pie, so to speak. And it's true. But prior to, I would say, the last few editions, it really was dealing with the lighting because the lighting was very inefficient in its design and everything. And now, with the lighting and electrical manufacturing industry kind of taking hold of the energy code, it's really been um, it's kind of gone on the downslide of things, but our controls are so much better to ensure that we are being really energy efficient. So number 8 in the list is our equipment and system controls. So let's talk about the controls that we have. Right now, what we have in our section of C405, we've got occupancy sensors, time switch controls, light reduction controls, which is basically dimmers, right? Ensuring that we have the capability of dimming where it's not just either on or just off. So it's a nice aspect to it. We have daylight responsive controls. Now, while we're going to talk about these today, next week we're going to do a deeper dive into daylighting and the controls that are involved with it. But it is part of the control, so we will touch upon it today. Then we're also going to talk about some controls that I would say are probably the least thought about. And it's the specific application controls. It's a section of the code that I think may not be utilized or as well known as some of the other ones. Our manual controls, because, hey, it's good to have controls that are manual controls. And then our exterior concepts of that, which is our exterior lighting. There's controls that are involved with that. And our parking garages, those have a specific call out. Now, we're talking about controls, lighting controls today. I did add the section with the controlled receptacles, just so that there is a good understanding with it, because there is some aspects of like the specific application controls that does tie into the controlled receptacles concept. And then we actually have some controls that are involved with in a section that I think a lot of times is not necessarily thought of, and it's the section that deals with other equipment, right? Our elevators, our escalators, those types of equipment also has criteria for the controls that are involved with it. All right. Now, you are required to comply with this specific sections here that talk about the lighting. Interior lighting for interior parking, it's going to direct you over to 405.2.9. The other type of lighting now says you're going to go with C40521 through 2.8. And so those are when we're talking about lighting, this is how we're going to address things. So this is just that overarching, hey, by the way, at the very beginning, you're going to do controls, and you're going to do controls that are specified by these particular sections. Now, there are some exceptions, and these are exceptions that we really need to kind of pay attention to and make sure that we're fully aware of. If somebody is to, state, hey, this is the exception. So our first exception deals with, is there a space that automatic shutoff could endanger the safety of the occupants or the security of the occupants? So anybody think of a space that might fall under this? This is where you guys type it into the chat.
Nothing yet.
Okay.
Got an electric room from Joyce.
Absolutely. I think electric rooms, it does make a lot of sense to maybe not have controls on it, because we don't want the lights going out or even being reduced as they're working on the electrical panel. I do understand why we would want, some controls there, in the sense that if they're not working on the electrical panel, does that light need to be on 24/7? No,
Also
it.
got stairways and egress corridors.
Oh, see, that brings up an excellent, it's a perfect segue into exception 2 here, that does talk about interior exit stairways, interior exit ramps, and exit passageways. But there are times that you might have egress that doesn't necessarily fall under that, but there is the idea here that we want to ensure that we get the people out of the building, obviously, but in a fashion that we aren't also adding to the energy efficiency of the place too. So that's why number 3 is in there, that talks about that emergency lighting. As long as that emergency lighting is lighting that would typically be off, then we wouldn't require that those controls be installed with it. So that's where we have to look a little bit and try to, kind of figure out, is there a way that we can merge kind of those two concepts together, right? Emergency lighting that is required out of the IBC, as long as that they are not provided with fire alarm systems. And then the last one is, if you happen to have lighting that's up to the 0.02 watts per square foot, that's in an exit access, the components involved with it, and it's provided with a fire alarm system for that.
Then we've got one here from lights at exterior doors.
So that is an interesting one. There is some criteria that is established for that. But there is a possibility, kind of dependent on what that exterior door is being utilized for, and in the fashion, it might fall under the exception, and it might fall under the criteria for the exterior lighting controls.
We also have Eric, who gave us the article from the 2020 NEC about automatic shutoffs not being allowed in electrical workspaces that have service equipment, switchboard, switchgear, panel boards, motor control centers, etc.
See, so that's why in this section, I think the a lot of times people think that it's either NEC or it's energy code, but there's a lot of overlap where we work together. So the energy code is saying, hey, we don't want anything that could endanger the occupant's safety and security. And the NEC is saying, yeah, we agree with it. We don't want automatic shut off in these locations. So I think that they marry quite well. All right. Do we have any others or should I move on?
Looks like we're done. You can continue onward, madam.
Perfect. Perfect. All right, let's talk about the fun and excitement of occupancy sensors. So, this is probably when we talk about lighting controls, the lighting controls that most people think of right off the bat, in my opinion, is they think of those occupancy sensors. And I'd probably say that's an adequate one because it's been one that consistently we know about, and it's really easy to probably grasp as far as is it on the plans, is it not on the plans, is it out in the field, is it not out in the field, right? And so the code has very specific locations that occupancy sensors have to be installed. And as you can see on the screen, we have quite a few listed here, just to name a few: classrooms, restrooms. I think we're all very familiar with occupancy sensors in restrooms. Corridors is a new one this go around. Open offices, enclosed offices, and then the kind of catch-all of the 300 square feet or less space and warehouses. My favorite though is whoops, where did it go? Oh, it was here. I'm missing it. Well, anyway, it talks about uh conferences. Oh yeah, there it is, conferences. And those people think of the small conference rooms, right? But there are places where it's a really large conference area, and that is one of the times that I appreciate when we have those occupancy sensors going on, because we're there, things are kind of set up really well, and when we're all gone, that it's gone. And a lot of times in those big conference areas, it also is tied into the daylighting. So it's just really nice because we get a lot of the natural light. Anyway, I digress. Let's talk about our occupancy sensors. So the next section of the code really talks about how we're going to navigate the section dealing with occupancy sensors. So if you are just an occupancy sensor, you're going to follow what we're going to talk about here in just a moment. When you are a warehouse dealing with the criteria for occupancy sensors, you're now going to follow the criteria out of C405.2.1.2, which we'll talk about. If you are an open office, now you have different criteria than what you're going to follow with the base, which is the 405.2.1.3. And the new section that came in, which is occupancy sensors for corridors. And that you're going to follow C405.2.1.4. I know corridors is a touchy subject, but don't worry. The energy code, I feel, is definitely combining the two worlds so that we can all play in the sandbox very nicely.
Well, we do have another question here. Is
Wonderful.
Are there any allowances for vacancy sensors? These are the opposite of occupancy sensors.
Yes. I'm going to say hold on to that question because that kind of falls into the realm of the function of these sensors. So some of them, they have to have the automatic on. And then some of them have to have where the occupancy sensor basically is shutting off when the person has left. In a lot of aspects, how it's kind of worded in the code, in my opinion, it's almost interchangeable, right? Because there's criteria for it to turn on when the occupants are in there, and there's criteria for them to either be reduced or turned off when they have vacated the space. So they kind of, in a little bit, they work hand in hand. All right, so let's talk about some of the functionality of the controls, and hopefully this will help with the question that we just had here. So if you are not one of these three, right? These three, we're going to do specific sections with very specific criteria to that use of space, right? If it's just, I need to install an occupancy sensor because I'm a classroom, right? Now, what we have to do is we have to have a sensor that turns off the lights 20 minutes after everybody has left the space. So this would typically be a vacancy sensor concept to it. The next function that it has to do is there has to be a manual on or an automatic on that's going to turn the lighting to 50%. And then you also have to have the option of where a manual control is going to allow them to just turn it off as they leave the space. Doesn't necessarily mean that you got to wait 20 minutes for the lights to shut off. I'm going to be out. It's 5 o'clock. It's the end of the day. Nobody else is going to use this meeting room. I can just turn the lights off. There are some exceptions to this, right? Automatic, full on, with no manual control is permitted when it's going to be in these following spaces. So it doesn't have to be the full 50 or it doesn't have to be the 50%. It can be at the full automatic on. And where it can happen is in corridors, interior parking areas, stairwells, restrooms, locker rooms, lobbies, library stacks, and areas where manual operation would endanger, safety and security of the occupants there. So you'll notice that when we talk about those occupancy sensors, a lot of times occupancy sensors are thought of that they'll turn on when somebody is there. And a great example of that is restrooms, right? Restrooms, the lights are off and they don't turn all the way on until we get into the room and it registers that, hey, we got movement going on here. So in that instance, we definitely have the full on occupancy sensor that it turns everything on. And then when everybody has vacated the space 20 minutes later, that's when it's going to shut off. All right, now warehouses. Warehouses are fun. Warehouses, what we're going to do is we are going to have occupancy sensors, and we are going to have occupancy sensors that are independent for each of the aisleways and the open area for it. And that sensor is going to reduce the amount of lighting by at least 50% within the 20-minute span of nobody being in that particular area. Now, it does have an additional option that instead of an occupancy sensor, they can have a time switch control that will be, it's on a timer. Everything is, shut off, whatever time they say, right? And then the other thing you have to also provide in this design is you also have to have a manual control. Now, open offices. Open offices are a little bit different than, like if you have an enclosed office, right? Because if it's an enclosed office, the person that resides in that office, when they're there, the lights are on, and when they're gone, the lights are off. When you have an open office, I could be here at my desk and doing my stuff, and then my cohort down the aisle, so to speak, might not be in that area. So it's been a interesting progression when this came in about how, talking about how you deal with it. So basically, it's really dependent on the size of the open office. If the size of the open office happens to be less than 300 square feet, then you're kind of treating it like it was a regular just space that needs an occupancy sensor. It just follows, the provisions that we have here, right? It shuts off after 20 minutes of people leaving the space. You can add a manual on of 50%, and then a manual control for occupants to be able to turn it off. If the space is greater than or 300 square feet and greater, now all of a sudden you're going to have where it's going to turn off that space 20 minutes after they have left it. A controlled zone cannot be larger than 600 square feet. And then you're going to have where the general lighting is going to be reduced to no more than 20% of lighting when people have left the space for 20 minutes. Makes sense? Now that I kind of stumbled over my words there.
So we do have a comment here from Todd. He says the assumption is that reducing the lighting by 50% can be either dimming by 50% or turn off half of the lights.
That's the question about whether you can dim it to 50% or whether it would have to be automatic.
Uh, I believe so, yeah.
Okay. So in this particular instance, when they're talking about that it has to be reduced to that 50% reduction concept, they're not stating or they're not allowing the use of the dimmer switch. That light reduction requirement is in a different section. In this particular instance, they're saying that it has to be an automatic adjustment for it, unless what they are referring to is here where it talks about a manual on or automatically turns on. As long as if it was like a flip switch, right? We'll just say a flip switch because I'm old. And you flipped it on, that would be considered that it can go to that 50% situation, but it's not where you're in this instance for section 405211. They're not talking about a manual dimmer on this one, because we're going to take care of that out of a different section. I hope that answers the question. If not, reach back out. I love questions. All right. The next one is talking about occupancy sensors for the corridors. Now, this one was obviously, I'm sure you could imagine at code hearings, it was very heavily debated. Because obviously, when we think about corridors, we think about corridors in the sense that we want to ensure that people, if there is an issue, they have to get out of the place, that they can get out of the place and it's not pitch black. So as you can see on the screen, it's only reducing it down to 50%. They are not saying that it must be completely shut off, as it does say with the occupancy sensors for some of the other locations. This one is just by 50%. And then again, it reduces to that 50% within 20 minutes of, people leaving the area for it. Now that reduction has to be reduced uniformly. So it's one that, they want it to be reduced and not like, you got it here, you got it there type of deal. They want it so that it's pretty consistent there. Now, there is an exception for this, because when we reduce it by 50%, we still have to keep in mind the concept of, the building code has a set foot candle that the corridor must be illuminated, right? And so the energy code recognizes that. And so basically, if you fall into the parameters where 50% puts you below that number of foot candles, then it says you're exempt because then you're already having a reduced amount of lighting in those areas. So corridors are not 100%, shut off the power. It does reduce down to 50%, but that's the extent of it. And if you think about it, I would say we've all stayed in a hotel and we've been in that corridor. You go out there at night, it's lit up just as much as it is, during the day. And so having a little bit of reduction in there would not hinder being able to get out of a building for it. Plus, it reduces when nobody's there. If you're out walking in that corridor, the light's turning on to that full extent. So, oops. All right. So if we were to look at this, right, for our occupancy sensors on here, is this information actually being provided for it? Because we need to have, occupancy sensors in certain locations. So we have a small storage, small maintenance. It says we have an occupancy sensor. It's on the wall. We have corridors. Corridors are being shown here. Toilet, stairs. It says C plans. It's on the ceiling. Vestibules, ceiling. So all of these areas, except for the mechanical, electrical rooms, IT, I'm not sure what MER room is, but the areas that would be deemed, and we talked about, would be deemed, health safety if the lights went off, are not having occupancy sensors. So when I look at this, I'm thinking, all right, they met the criteria as far as ensuring that they have it. So this is their lighting control schedule, but it's not their sequence of operations, right? Because they all have different things. Is it shutting completely off? Is it only 50%, right? So that information, the sequence of operations we would need, but at least having the occupancy sensors, are actually illustrated here. And here's a great one to look at for this. So we have, as far as when we're looking for the automatic controls here, we're going to look at this one. So we have S, T, N, B, and Note 5 and S. So this data center is saying that we have S. So now we're going to come down here and it says Note 5 for S, that says the sensor will automatically turn off the lights after the space has been vacated and the timeout period has expired. That is meeting the intent. It should say 20 minutes on there, but at least we're getting the information that we need. And typically this is not unusual that I'll get a lighting control and then I have to go to a different area to get what the sequence of operation is for that particular lighting control. So that way, when you're out in the field, you know that you kind of have to look at multiple locations on the plans, as the contractor or as the inspector out there doing it. So the next section that we're going to talk about here is the time switch controls. So if it doesn't have an occupancy sensor, it now is required to have a time switch control unless you fall under one of the exceptions in here. And I think a lot of these are very similar. The last one dealing with shop and laboratory classrooms, I think we probably want to ensure that as they're using the saw, the lights don't go off. I think that is understandable. You would think it would fall under the endanger the occupant's safety and security, but I appreciate the fact that they specifically call out shop and laboratories, right? We don't want them being messed with. All right, so what do these controls have to do? Well, that's a great question. Let me tell you. So your timer has to have where it will automatically turn off the lights when the space is scheduled to not be occupied. So if you are only open Monday through Friday, then, hey, Saturday and Sunday, you don't need to have the lights on. So it also has to have a 7-day clock and have the ability to set it for 7 different day types in that week. And as I mentioned, right, you're only Monday through Friday. You don't need lights on Saturday and Sunday, so you program it that way. You also must have the capability of being able to program holidays into the system. So if nobody's going to be in the office for Halloween, then we don't need the lights on. Now, since you've spent all this time programming this sucker, now we want to ensure that if the lights go off, the power goes off for, a couple of minutes, that all that programming is not down the drain, right? So what the code requires is that your system has to have program backup, that it won't lose any of the programming for at least 10 hours of the power being interrupted. So it has to have the capability that if the power's out for 10 hours, that the same programming will be able to be available for it. It can be longer than 10 hours, but the minimum is 10 hours. You also have to have an override switch. Now, this override switch, you're able to have it as a manual control, but basically what it says is, hey, you know what? Normally we're all out of here by 5 o'clock, but we're going to do inventory. So we're going to be here for a couple of extra hours. So we're going to flip the override switch. Well, that override switch is going to allow the lights to be on for an additional 2 hours. Now that override switch can do a space that's up to 5,000 square feet. So you may have to have, if it's larger than 5,000 square feet, you're going to have multiple override switches for that. All right, there are some exceptions to the time switch control. And this is for concourses, auditoriums, sales areas, manufacturing areas, and sports arenas. If it's greater, or you can have it for greater than 2 hours, if you are going to utilize a captive key device. That means you have this like little, card here. I don't know if you can see it, but these little like hotel cards, you put it into this device. And so the lighting stays on as long as this card is in place. Once you move it, then, the lighting is done. And then again, this is, you're only allowed to do up to 5,000 square feet for that one area. And that's only if the entirety of the space is less than 20,000 square feet. So here's my favorite. This is at the Denver Broncos arena. It's 10 o'clock in the day, and you can see, blue, clear skies, and all the lights in the stadium are on. All right, so here's an example too of it being shown on the plans. And as you can see, we have a vestibule right here. It is on a controlled time clock. And it says, well, our programming is 1 hour. It's going to turn on 1 hour prior to the business, turn off 1 hour after the business closes, and provide a 2-hour override at local wall station. And then it shows, hey, I'm the local wall station right here. So, not too bad. Not too bad. It meets the criteria of what we're talking about here. All right. So now we have our light reduction control section, which in later editions of the code, it calls dimmer controls. So just so that we're all on the same page, that they're kind of referring to as dimmers here. But what they're saying here is if you don't have an occupancy sensor, then what you're going to do is comply with this section. Now, there's some exceptions, the big one being daylight controls, because those daylight controls are already on a dimmer, right? That's kind of what the daylight controls functionality actually is. Now, another one that is exempt is the special applications. And that's because with that, they have their own criteria of what they have to do with it. So what you are going to do is when you have those manual controls, if it has one luminaire with less than 60 watts, you have a space that uses less than 0.45 watts, or your corridor, lobby, electrical, or mechanical rooms, you happen to be an exemption for it, and you have that manual control there. All right. You have to have a manual control that's going to reduce the lighting by 50% in a uniform pattern, right? Whatever that's going to be. It has to have the ability for that continuous dimming that's going to go from full and reduce it all the way down to not less than 20. You're going to have a switch to reduce the output to not less than 30 and not more than 70. So as you can see here, we got 50% for lights, right? So this switch that we see on the screen there would meet that criteria already. Now there is switching alternate luminaires or alternate rows to have a reduced output. And that one is, again, that's the same concept, right? It's not less than 30 and not more than 70%. So you're not shutting it off all the way. You're not turning it on all the way. It's giving you the ability for somewhere within that realm in it. All right. We are going to talk about daylighting controls in the sense that, kind of a brief one. Next week, Troy's going to do a deep dive into the daylight responsive controls, all the sections that are kind of involved with it. But it would, be bad of me not to talk about them when we're talking about lighting controls. So lighting controls, when we talk about daylighting controls, there's two kinds of daylighting that's involved. We have our side lit daylight zones, and then you have your top lit daylight zones. So when we talk about side lit zones, you're going to have a primary and a secondary zone. Basically, here's your primary, you double it over, and it's your secondary zone. In your primary zone, if you have 150 watts of general lighting, it will trigger the requirement that daylight responsive controls must be included into the design. Or if when you add the general lighting of the primary and the secondary zone, and the two zones equate to 300 watts or more, then you're going to have the daylight responsive controls installed. And we'll talk about how to figure that out here in just a moment. And then also, if you have a top lit zone, which, when you have a skylight, in that top lit zone, if you have general lighting that equates to 150 watts or more of lighting, you will then be required to have the daylight responsive controls in there. Now, there are some exemptions, healthcare patient rooms, first floor, or that's above grade for A2s or Ms. And then if you have a total connected lighting power calculation equation, calculated equation utilizing equation 4-10, and it's less than the adjusted lighting power allowance with equation 4-9. That was a lot of fun. So for our, what constitutes a side light and what constitute a top light area, remember, just about every time you have a window in a building, it quantifies as a daylight zone. And then every time you have skylights, that will quantify a top lit daylight zone.
We do have a question here, Hope.
Oh, yes.
Can you tell us why the top lit zone was deleted in the New Mexico IECC?
Oh, that's right. It was. I think that they just decided that it was going to be deleted. I can't remember honestly, the discussion about it. All right. Well, let's talk about the side lit zones here. So for our side lit zones, how you determine how you're going to calculate it, right, is we have our windows. And remember that when we talk about side lit and windows and skylights, that 60, that number 60 is really important because it is a side lit fenestration when it's greater than the 60 degrees, because that's our vertical fenestration. So you might have angled windows that you think were skylights, and they're actually not skylights. They're actually windows because they hit that 60 degrees there. But anyway, how we are able to figure out what our daylight zones are going to be is you are going to measure from the floor to the height of the window, and then it will say it's 10 feet, right? So then we've measured, we're going to lay it down on the ground, and we measure from the window out 10 feet. That's your primary daylight zone. Then we double it up and we measure again another 10 feet, and that's our secondary daylight zone. So basically, from the window, we would measure out 20 feet, cut it in half, and we got primary and secondary daylight zone. Now, that's just the depth of it. To measure the width of it, because lighting doesn't just follow the edge of the window, it's going to spread out a little bit, right? It likes a little bit of room. You're going to measure half the height from the floor to the height of the window. So if it was 10 over here, that means we're going to measure out 5 feet. And that's the distance that we would be looking at there. Now, our daylight responsive controls that we're going to put in our primary and secondary zones. This is the criteria that we have to have. So each of those zones, if they are quantifying that they have to have the controls for it, there has to be a control that's independent of each other. So you couldn't have one control doing both the primary and the secondary. You have to have a control that does the primary and a second control that's going to do the secondary for that. There has to be the ability that you can calibrate it, and it has to be within the space that it is, and it has to be accessible. Ready, let me rephrase that, has to be ready access, meaning it can't be 10 feet in the air. It has to be at a location that Hope could walk in the room, pull out her little calibrator, and be able to easily get to it. I don't have to climb on a 10-foot ladder and arch backwards because the calibration is up on the ceiling, right? We want to make sure that we're able to maintain it. Now, the other thing it does have to do is it has to have the ability to go from where it's fully on all the way down to 15% of the lighting, right? Because if I have a wall of windows and I'm facing east in the morning, I probably don't need my lights on because I have all of this light shining through, natural light, even better, right? Coming in. But in the afternoon, when the sun is, on the other side of the building, I'm going to need some lighting in my area. And so that's kind of why it talks about the different dimming on that. You do have to have a control that's going to shut off all of the lights, occupancy sensors that reduce the lighting in those unoccupied areas within the code, and the additional controls for the levels and the power. And then this is the fun one. This is the bullet point that's a lot of fun, because you could have a zone that is kind of facing two directions, right? It's right there on the corner. It's facing both east and it's facing north. I was going to say east and west, and that just isn't going to work. And so in those instances, when you kind of have that, you're going to have controls that's going to do the zones independently. So there may be a time that it makes sense that the lights are, on a little bit more when it's facing this direction than it would be that direction. Anyway, all right, so let's talk about the occupancy sense or the not the specific application control. So this is a really fun one. So as you can see here, we've got a display case, right? So in this instance, these items have to be controlled by an occupancy sensor or a timer switch, and they also have to have a manual control. So if you recall, we talked about this last week, the opportunity that if you went with the space by space method, you're selling goods or you're, highlighting artwork, that you get the ability that you get to have additional lighting power density. Now, the trade-off for that is you will be required to install an occupancy sensor or a timer switch with that additional lighting. So that's what the first bullet point is talking about. The second one is, and the third one, the lighting that's in those display cases, right? We've all been to the grocery store. Well, I think most of us have been to the grocery store, and you look and you're in the freezer aisle and the lights are off in the little display cases. And then you open up the door and the lights pop on. That's because they're all on occupancy sensors. And so that is a requirement that's there. If you have supplemental task lighting, it's got to be on occupancy sensor timer. Lighting for sale or education. So let's say you go to Lowe's, right? Or Home Depot, any of those, big box stores or whatever, and they have that aisle with all of the lighting available that you can buy, and they have all that lighting on. So that lighting has to be on an occupancy sensor, on a timer to turn it on and off, basically. And then, as I mentioned before, with the selling of the goods, right? The lighting, the extra lighting that's being used for the displaying of the exhibits and art displays at galleries and museums, all of that does require to be either on an occupancy sensor or a timer too. Whoops. There we go. So now let's talk about how these sensors are supposed to function. So if you do an occupancy sensor, it's got to shut off after 20 minutes. You can have an on-off switch or an on switch that's going to turn it on to 50%, and then a manual control that's going to allow it to turn off for the occupants to be able to turn it off. And then the timer, it's just like the other one, right? It's got to have the ability to do a 7-day clock, different times per week, incorporate holidays, have backup. It also has to include an override switch. And the override switch, you have the ability that you can use it as a manual, but it can't go beyond 2 hours on that. Now let's talk about this one. This is a fun one that goes into the specific applications. So this is the one where I wanted to, I brought in that controlled receptacle concept with. So in this instance, when you have a sleeping unit, so this pertains to the hotels, right? Sleeping units have to have a control that's automatically going to turn off the lighting and the receptacles, 20 minutes after everybody has left. Now, there is that possibility, right? The use of a key card where you put it in there. It can be utilized so that it stays on for, longer than the 20 minutes, because you could be sleeping and, roll all that fun stuff. So it allows you to kind of do it yourself. The second exception deals with patient care, right? So in this instance, sleeping in rooms in a patient care doesn't necessarily have to fall under these provisions. So lighting in dwelling units, when they happen to have occupancy, there needs to be that occupancy sensor or light reduction control. If you have lighting for plant growth and food warming, it's got to be controlled by an independent time switch from all the other type of lighting. So the lighting to keep the food warm is going to be different than what the rest of the general lighting is going to be. And then task lighting for medical and dental purposes can have that manual control there. All right, yeah, so that's the example of a key card. All right, let's talk about our manual controls. So you've got to comply with it. It's got to be in a ready location for everyone. It's got to be visible. So not only does it have to be in an inaccessible location, it also has to be visible. So you can't necessarily hide it behind something. And then you also have to let them know where it actually serves in that location. Because there are times where you might have a large room but gets divided up, and you have to have those controls that says, oh, this is going to do this space, this one's going to do that space, so that everybody's all on the same page. All right, exterior lighting. So you're going to have to comply with C405 2.71 through 4. There is some exemptions to this, one being covered vehicle entrances and lighting that's going to be controlled by dwelling units. And that's because if you think about it, you're in an apartment, you need to be able to control when you're going to be going out onto your patio that you want the lighting actually on. And that's kind of what they're talking about. And the covered vehicle entrances, this is a leftover because in this particular code, they actually have a new criteria for it, and they never removed it out of here. Whoops. So the first control is everything shuts off when there's enough daylight present. So as you can see here, this is an example of, I don't know if you see the big blue sky up there. That indicates that there is enough light out there. So this is the same parking lot. This lighting is off, but this lighting is still on. It just was one end of the parking lot to the other end of the parking lot. Building facade and landscape lighting. So your building facade and landscape lighting has to shut off an hour after the business closes and turn on no earlier than an hour before the business opens. So you should be seeing like a sequence of operation for that. The next one is dealing with the setback. And this is when you're not talking about like, your building facades and your landscaping. This is going, beyond that type of stuff. In this instance, what you're going to do is you're going to have a control that's going to reduce it by 50% in one of the three options. So it's either going to be reduced to 50% from midnight to 6 a.m., or it's going to be reduced to 50% 1 hour after closing and turn back on 1 hour before opening, or turn off when there is no activity present for 15 minutes. Now, there is a separate criteria for our exterior parking lighting. And this is for when you have exterior parking lighting that's greater than 40 watts, but has a height that's 24 feet or less. So I'm sure we've all seen on a set of plans where it calls out that the lighting pole will be 20 feet or it's going to be 22 feet. And the reason is because that's when this kicks in and not the other components kicks in. So when it's less than 24 feet or less, then it doesn't shut off completely. It just reduces down to 50% when there isn't any activity for 15 minutes. And the controls, you can have them controlled together, but it can't be more than 1,500 watts that are controlled together. Now you do have to have a time switch for your exterior lighting. And again, just like for the interior, it has to be able to be programmable for 7 days with 7 different days of the week, have holidays incorporated into it, and have the ability that you can maintain your programming for 10 hours in the event that the power is actually interrupted. So here's an example of it here, and it says hours of operation. It's only going to be on from dusk to dawn. Exterior lighting to be controlled by the library's control panel with photocell and timer. So this note lets me know, okay, I need to go into the sequence of operation and ensure that is in there. Now, here is another new section that came in. This is dealing with parking garages. So parking garages are required to be on occupancy sensors or timers. Now, it does not shut the lighting off completely. It has to reduce it down to at least 30% or no more than 30%. After 20 minutes of nobody being in the space. Now, these zones are zoned even smaller because they cannot be anything larger than 3,600 square feet. There is an exception again, and it deals with the foot candles because of what is listed in as criteria for the IBC. Now, this is the section that I was referring to earlier when we're talking about entrances and exits and allowing for that eye adaptation. So what it does is it says reduce it to that 50% so that you're kind of gradually getting used to it. Because I don't know if you've ever been, driving around, it's sunny and you're getting into a parking garage that a lot of times, they're underground and you go down and it is really dark. I end up stopping and I'm like, ooh, I got to adjust my eyes because I can't see where I'm going and I don't want to hit anybody. I don't want to be on the news for that. So it incorporates those types of criteria for it. It also requires for daylighting criteria. So if you have a open garage where you have openings within the walls of the garage, you will incorporate daylight criteria with it and have the daylight responsive controls included with it. So this is kind of what we're looking at here. So you can't do a space that's larger here, and it should be on occupancy sensors. And again, here's where we're dealing with an entrance and how it is, the lighting is being reduced enough so that we aren't, like shocking all of us. And then here's an example. You can see how much daylight is coming through and why they're requiring that daylight be a conversation that needs to be had when we have this type of a parking garage in here. All right, another lighting, it's not necessarily a control per se, but just something to be aware of is that your voltage drop cannot exceed more than 5%. And typically what I get with this is I get a note on the plans, as you see here. And then automatic controlled receptacles, 50% of them you're going to have in these particular locations. You can either do where it's a split or have one full controlled receptacle, one non-controlled receptacle. You have to have it where, 20 minutes after everybody has left, they're shutting off. You also have to ensure that they're marked, which isn't a big deal because the NEC also requires for all of that to be in here. So let's talk about the section that probably doesn't get a whole lot of conversation. So elevators. Elevators have criteria when it comes to the amount. Oh, I missed that was removed for New Mexico. Elevator cabs cannot have more than 35 lumens per watt within that cab of lighting. Now, they also have criteria for the amount of ventilation that is permitted. Now, why I bring this in here is because the controls that are involved with it needs to de-energize both the lighting and the fans when there has been no activity. The doors are closed and there has been no activity for 15 minutes. All right, everyone, that is it. Thanks for hanging out with us. Here is the helpline. You have questions, submit it to us, and we are happy to answer your questions. Don't forget that we have the new website ready to go for you that houses all of our technical documents, so you can get on there and have fun with that. Next week, we're going to do daylighting with Troy, and we're going to have a survey. Let us know. And as always, feel free to reach out to us. I hope you all have a fantastic day.
Thank you, everybody.